Okay, so letter C, if you look at the directions, it says solve the following equations for y. So we want to get and isolate y by itself, okay? So I'll do this one together, and then we'll probably see if you can do D on your own. Y, again, is right here. It's currently being multiplied by 2, okay? We're going to keep those together, but we have this other couple, I call them couples, -5 and x. They have nothing to do with y. They're on the same side right now, but we need to move them to the other side. How would I move that mathematically?
0.
What about 0?
0. Wait, which one you moving?
I want to move the -5x. Right, I'm going to add it because that will move it mathematically to the other side. Because whatever you do to one side of the equation, you have to do to the other. So my 5x's are going to cancel out. I'm left with 2 times y equals, can I combine 10 plus 5x? No. So I'm going to keep that just as it is, 10 plus 5x. I am trying to solve for y. I want to get y by itself. Right now it's being multiplied, so I will divide by 2. And then every other term, thanks TJ, you just divide by 2. Now, you can put it all together like this and say divide by 2 and look at them separately, or you can divide them up and divide each one by 2. So the 2 simplify out and you have y is equal to 10 divided by 2 is 5. All right. And I have 5 over 2 times x. What kind of form is this written in? It is y equals mx plus b. Do you remember what it's called? Slope-intercept form. So slope-intercept form, we usually have the x written in front. So if you're a little bit more of a mathy person, if you like math, appreciate it, yes, we would probably rewrite it as y equals 5/2 x plus 5. And what would be my slope here? 5/2. Don't say 5/2.
5 over 2.
Okay, but don't say 5 over 2. 5/2 or 5 divided by 2. And b is equal to,
5.
and 5 is my y-intercept. What kind of a graph would this be? Linear. It's a straight line, okay? And you would go up 5 spaces and to the right 2. Yes? I don't know. Can you? Do you have a card? Uh-huh. A pass? Okay. So go over there, fill it out, bring it up to me. All right. So let's go to D. I want you to try D on your own if you haven't already. We are solving for y. Solving for y. You want to isolate y by itself. Let me get this other one up. It's at the bottom of page 11. Did you fill it out? You fill out the date, the time, where you're headed, and then I will just sign it. Yep, on my desk. So trying to isolate y, get y by itself. Just a reminder also, I will be here tonight after school for an hour. Anybody who wants to come, you don't need to tell me. You just come here at 2:25, between 2:25, 2:30, 2:35. Get here, and we will work on some problems.
Oh, shit, I work around time. I work 7:30.
All right, I'm guessing most people have a pretty good start. Sound like the Kool-Aid man. Oh, yeah. All right, so we need to, if we're solving for y, we're going to keep the y term on that side. I want to move this negative 9x. So I'm going to add 9x. Whatever you do to one side, you have to do to the other. This is the addition property of equality. You're adding the same thing to something that is already equal. Don't forget the sign in front. So this is negative 3y equals negative 18 plus 9x. I can't combine those because that's xylophones and a number. So here I want to isolate y. I am going to divide by negative 3 with both terms. The negative 3's simplify out because negative 3 divided by negative 3 is 1. 1 times y is y. What is negative 18 divided by negative 3?
It is actually
6. And 9 divided by negative 3 is negative 3x. You could put over 1, or you could just leave it as negative 3. And because I'm a little bit more mathy, I'm going to switch these around and say y is equal to negative 3x, there's my negative right here, plus 6. But I would take either one of these. Either is correct. If you want to impress me, though, go for the second one. Okay? Any questions about those? No. Let's get to some harder stuff.
What page is homework on 43?
That homework is on page 43 and 44. We're not done for the day, though. All right, so let's go to the next page. Writing equations. Writing equations. This means we are looking at the words that are given to us and we are interpreting them and rewriting them as mathematical equations. All right, so there was a big player back in 1962. That's even before I was born.
What champion?
Wilt Chamberlain. Wilt Chamberlain set the record for the most points scored in a single NBA game. He scored 28 points from free throws. Okay, so that's where you're at the line and people are on the sides. He made X number of field goals. A field goal here in basketball is worth how many points? A field goal in basketball.
I don't know.
Is it 5?
When you shoot a basket, it's worth 2 points. So we need to know that field goals in basketball are equal to 2 points. We need to know that. How about free throws? How much is a free throw? Free throws are 1 point. So if you're not very well versed in basketball, you do need to know this. Free throws are 1 point. Okay? Oh yeah, it says it later. 2 points each. If Wilt Chamberlain scored 100 points, how many field goals did he make? Which equation represents the number of field goals that Chamberlain scored? So let's take a look at them. A says 100 equals 28 plus 2 times x, where x is the number of field goals. Letter B says 100 equals 28 times x plus 2. Letter C says 28 is equal to 2 times x. And letter D says 100 is equal to 2 times x. Now, is there something here that you're like, I'm pretty sure we can get rid of this one?
The 28 equals to us.
C? Okay, so 28 points. He scored in free throws. And they're saying 28 points is equal to 2 times the number of field goals he made? No, because it wasn't even a field goal. Those were his free throws, right? So we can cross this one out. Which one? B. D, I would say D. We definitely can take care of D. So we've got the 100 points total equals 2 times the number of field goals. But they didn't even put anything in there about his free throws, right?
Yeah.
So that's out. Now we're looking at A and B. Those are probably the two best choices. They both total 100 points. And what is kind of the telling factor to you? Which one do you think is correct? A. Why? This 28 represents what again? That's the free throws. And they're each worth 1 point. So, 28 times 1 is 28. Plus 2 times x, which is your field goals. And each field goal is worth 2 points. So yes, A is the correct choice there. He didn't score just 2 points in free throws for this one. So it's not B either. Okay? Actually, let's solve this. All right? I know. So let's write it right over here. 100 equals 28 plus 2x. I'm trying to solve for what again? X, your variable. So we need to get the numbers to one side, the variables to the other. We are on page 12. Page 12. So mathematically, what would I do first here? Subtract what? Subtract 28, subtract 28. That cancels out. Bring down the 2 times x equals 100 minus 28 is going to be 72. I'm trying to solve for x. Divide by 2, divide by 2. X is equal to 36 field goals. That's a lot. 36 made shots. We don't even know how many he didn't make. 36 field goals. Plus the 28 from the free throw line. 100 points, that's a lot. That's like a total of a whole team score sometimes. It's crazy. Wilt Chamberlain. All right, any questions about that basketball question? Let's go to example 2. Write and solve an equation. The diameter of the earth. All right, got to think back a little bit. Which of these is a diameter? Is it A? Is it B? B goes all the way across. Is it C, which goes all the way around? Or is it D? Which one is the diameter?
It's C.
It is not A. It is not C.
It's big.
It is B. Yes, this is the diameter. It is the distance that goes all the way across, and it also has to go through the middle. So that's what we're talking about, the diameter. The diameter of the earth is 828 kilometers less then twice the diameter of Mars. If Earth has a diameter of 12,756 kilometers, what is the diameter of Mars? So we're looking for the diameter of Mars. We have to turn these words into an equation. So the words say the diameter of Earth is 828 less than twice the diameter of Mars. Okay? So they're helping us set it up. The diameter of Earth means equals 828 less than. How am I going to show that? How do I show 828 less than something? Minus 828. So this right here is going to be minus 828. And it's less than twice the diameter of Mars, which they have as 2m down here. So down here we put minus 828. M is equal to our variable, that's the diameter of Mars. Diameter of Mars, which we don't know. But the diameter of the Earth, they said, is equal to twice the diameter of Mars less 828. And they also tell us that that diameter is 12,756. So 12,756 is equal to 2 times the diameter of Mars minus 828. But you have to look at each phrase and say, what does this represent? And if you say, I think this is really important. If you say 828 less than, that doesn't mean 828 minus something. It means it is smaller than whatever follows. Okay, so this is the correct interpretation. 828 less than something, it is smaller than what you have before. All right, so all we did here is rewrite this equation down below. We're trying to solve for M, the diameter of Mars. Get your minus 828, move it to the other side. So I'm going to add 828, add 828. 828s cancel out. 2M is equal to 6 and 8 is 14, carry the 1, check my math. 5 and 2 is 7, and 1 is 8. 7 and 8 is 15, carry the 1. 2 and 1 is 3, and 1. And so I can read it better, put some commas in. Well, I don't need to read it. I guess that wasn't the last one. That is 2 of the diameters of Mars. I just want the diameter of Mars. So divide it by 2. Divide it by 2. M is equal to, oh my gosh, long division. Have you guys done long division?
No.
I just use a calculator. So 2 does not go into 1. It goes into 13 6 times. Check my math. Bring down the 1, then bring down the 5. 2 goes into 15 7 times. Subtract, you get 1, bring down the 8. 2 goes into 18 9 times. Subtract, I get 0, bring down the 4. 2 goes into 4 twice with no remainder. So M, the diameter, is 6,792, what? Pink tutus?
Yeah.
No. Kilometers, I believe. Yes. Kilometers. It's always good to label. Questions on that? How are you guys feeling about solving equations. I think you're pretty good at solving equations. Now the writing, yeah, that takes a little bit more practice. Okay, let's go to this next part and see if we can get example 5 done, and hopefully we'll stop when we get to the learning linear inequalities. We'll finish that up tomorrow. This is very important. Let me stress this again. This next section is really important. People have a little bit tougher time understanding it. So, talking about a tower race. The Empire State Building run-up is a race in which athletes run up the building's 1,576 stairs. In 2003, Paul Craik set the record for the fastest time, running up an average of about 165 stairs per minute. It's pretty good. Very good. The function C equals 1,576 minus 165 times m represents the number of steps Craik had left to climb, which is C, after m number of minutes. Find the zero, underline that zero, find the zero of the function and interpret its meaning in the context of the situation. Okay? So step 1 says graph the function. Well, the graph is already there for us. Okay? This is his rate of running. Now, for math purposes, what do you notice about this line? What does that say about his rate? It's constant. Let me ask you something. If you're actually running up a bunch of stairs, do you think your rate is going to be constant the entire time? No. Because the higher up you go and the more you've been doing it, your time is going to get slower. Your rate is going to get slower, okay? But this is for a math. It would be much more difficult for us to figure out if we actually did his actual rate. Okay. So it says the graph appears to intersect the x-axis. Okay, find your x-axis right here. It appears to intersect the x-axis at about what point? 9.5. Yes, you guys need to realize if here's 9 and the next one, as you can tell, they're all going up by ones, that looks to be in the middle. So between 9 and 10 is going to be 9.5. So we put 9.5 in that first blank. That means that Paul Craik finished the race at about 9.5 minutes, or, so 9.5 is how many minutes and how many seconds? First of all, how many minutes is 9.5 minutes? 9 minutes. And then the 0.5 is half, right? 0.5 is equal to 1/2. And then how many seconds are there in a minute? 60. So there are 60 seconds in 1 minute. So we want half of 60, which is going to be 30. 30, right? So 9 minutes and 30 seconds. Does everybody see how I did that? You're just multiplying. Half of 60. 1/2 times 60 is 30. All right. So what is happening right here when he reaches 9.5 minutes? He stops. Why is he stopped? He's done. So I want you to write this down because we are going to be interpreting some graphs. So at 9.5 minutes, he is stopped because he is done racing. If you look, he is at 0. Okay, actually it looks like he's going down. He stopped, he is done running. Okay. What about at this y-intercept?
That's where you start.
That's where he started. How high up was he? That's where he started. How high up was he? Or wait, actually this has to do with steps he has remaining. Sorry. How many steps did he have to do at that point? And actually, it looks like 1,600, but it's a little bit lower because they tell you in the problem it has 1,576 stairs. So it's a little less. Do you see how it doesn't quite go up to 1,600? Yeah, so that is 1,576. So when he is first starting out at 0, this is the time he hasn't started. He has all those steps to go yet. Okay? So that's what this means. That's going to be important in the coming number of problems. Now, let's solve this algebraically. So, using the equation, substitute 0 in for C. 0 in for C and solve algebraically to check your solution. Now, what is C again?
C is. Wait.
Number of steps Craig had left to climb after a minute. So we're saying he's done. We want to know how long it actually took him. So we're going to set C in for 0, or 0 in for C. 0 equals 1,576 minus 165M. I want to get variables on one side, numbers on the other. I am going to add 165M. I'm going to actually move that. I could have moved the other one, but this is going to make it positive on the other side. So these cancel out. I have 165M is equal to 1,576. Divide by 165, divide by 165. And I get M is equal to, I think you're going to get on your calculators 9.55 something, 0.551 maybe. So the solution is about 9.55. So he completed the Empire Building Run Up in about 9.55 minutes, or 9 minutes and... Now, if I do 0.55, I have to do 0.55 times 60. It's not half of 60. We're being a little bit more precise here. Okay, so 0.55 times 60 is how many seconds? 33? So this is a little bit more precise. This is close to the estimated time of 9.5 minutes. All right. So we will stop there for today. Homework. If you have not already, you need to start on homework 9.1. You should be able to do all of the front and probably part of the back. This is due on Friday. Please try to get your homework done closer to the time of when it's due, okay? That benefits me in grading, and it benefits you in making sure you know how to do it. All right, let's see if we can get some announcements. Good job today, guys. Appreciate your help.